Hello everyone, and welcome back to my YouTube channel. In this video, we're going to talk about two important topics, SQL data types and schemas. I will walk you through these concepts step by step. If you're new to these terms, don't worry. I'll break them down in simple and easy to understand language. So, let's dive in. If you're working with databases, understanding data types is very important. And if you are new to databases, you can watch my first session video and then return to this one. Okay, so let's learn data type. So, what are the data types in SQL? In SQL, data types are used to define what kind of data can be stored in a table column. Each column in a database table must have a defined data type, which determines the kind of values that can be inserted into that column, such as integers, floating point numbers, text, dates, or even binary data. This is important for ensuring data integrity and optimizing storage. Let's look at a quick example. Imagine you're creating a table for storing employee information. Here, the integer data type is used to store the employee ID. VARCHAR variable character, 50, is used to store the employee's first and last names. Date is used to store the hire date, and decimal is used for storing the salary with 2 decimal places. So, understanding SQL data types helps ensure that your data is stored correctly and efficiently. Now we're going to talk about the 3 main categories of SQL data types. Understanding these categories is essential for organizing and managing data in your database effectively. Data types in SQL are classified into 3 main categories. First up, numeric data types. These are used to store numbers, whether it's whole numbers, fractions, or decimals. Common examples include int for integers, float for floating point numbers, and decimal for precise decimal values. Next, we have string data types. These are used to store sequences of characters like text, numbers, and symbols. You'll frequently use VARCHAR for variable length strings, CHAR for fixed length strings, and text for longer text data. Last, we have date and time data types. These store dates and times, like specific days or timestamps. Key examples are date for just the date, time for the time of day, and date time for both. These types help you structure your data efficiently, ensuring that each piece of information is stored in the best possible way. Let's break down these categories one by one, starting with numeric data types. These types are essential for storing numbers in various forms, whether whole, fractional, or with precise decimal points. First, we have the int type. It's called integer, which represents whole numbers without any fractions. It comes in different sizes like small int, and big int, to accommodate various ranges of values. For example, it can store numbers like 1, 42, or -100. Next is the decimal type. This is used for numbers with a fixed number of digits after the decimal point, making it ideal for precise calculations, especially in finance. The decimal and numeric types fall under this category, with examples like 12.34, 100.00, and 0.01. Third, there's the float type, which is used for numbers with a fractional part. It's capable of handling very large or very small numbers, but the precision can vary. This category includes float, double, and real, with examples like 3.14, 0.001, and 2.71828. These numeric data types give you the flexibility to handle all sorts of numerical data in SQL, from whole numbers to precise decimals and floating point values. Let's look at an SQL example using the different numeric data types. Here's a simple table creation script that demonstrates how to use integer, decimal, and float. Here, employeeInt stores integer values for unique employee identifiers. Salary, decimal, 12, 2, stores the employee's salary with precise calculations, allowing up to 12 digits in total and 2 decimal places, e.g., 50,000.00. Bonus float stores the employee's bonus, which may include fractional values, e.g. 1,234.56 or 500.75. This table helps manage employee data with unique IDs, accurate salary figures, and flexible bonus amounts. Now let's see string data types in SQL. These types help you store text data in various formats. Let's break them down. First is CHAR. CHAR is called character. CHAR data type stores fixed-length strings. If you specify CHAR 10, it reserves space for 10 characters, even if your string is shorter. For example, hello will still use space for 10 characters. Next, we have VARCHAR. VARCHAR is called variable character. This one is for variable length strings. It only uses the space needed for the actual content. So with VARCHAR 255, you can store up to 255 characters, but hello will only take up 5 characters of space. Then there's text. This type is used for very large strings, perfect for lengthy content like articles or descriptions. It can handle an entire paragraph or more. Fourth, nchar and nvarchar are for Unicode characters, supporting international text. Nchar is fixed length, while nvarchar is variable length. For example, nchar 10 can store konnichiwa, Japanese for hello, and nvarchar 255 can store bonjour. Understanding SQL string data types will help you manage and store text data effectively. Let's look at an SQL example using the different string data types. Here's an example of an employees table that uses different string data types. Employee ID int stores unique identifiers for employees as integer values. First name, CHAR 20, fixed-length string for employee first names, using 20 characters of space regardless of the actual length. Last name, VARCHAR 30, variable length string for last names, up to 30 characters, using space only for the length of the name. Bio text, large text field for detailed biographies or descriptions about the employee. Email, NVARCHAR 50, variable length string for email addresses, supporting up to 50 characters, and Unicode for international characters. Now, let's see date and time data types in SQL. These types help you manage and track dates and times in your database. Let's break them down. First, the date type. It stores only the calendar date, with no time information. For example, date 2024-August-24th captures August 24th, 2024. Next is the time type. This one stores just the time of day, excluding any date. So, time 1430 represents 2:30 p.m. Then we have date time or timestamp. These types store both date and time together. For example, timestamp 2024-8-24-1430-000 captures August 24, 2024 at 14:30 hours, 2:30 p.m. Finally, the interval type. This represents a duration rather than a specific point in time. For example, interval 2 hours represents a duration of 2 hours. Understanding date and time data types will help you track and manage temporal data effectively. Let's look at an SQL example using the different date and time data types. Create the employees table with date and time fields. Employee ID int, a unique integer number for each employee. First name CHAR 20, stores the employee's first name with a fixed length of 20 characters. Last name VARCHAR 30, stores the employee's last name with a variable length up to 30 characters. Hire date, date, records the date when the employee was hired, e.g., January 15th, 2020. Birth time, records the time of day when the employee was born, e.g., 8:30 a.m. Last promotion. Timestamp, tracks the date and time of the employee's last promotion, e.g., January 1st, 2024 at 9 a.m. Contract duration. Interval, indicates the length of the employee's current contract, e.g., 2 years. This example demonstrates how to use date and time data types to manage employee-related temporal information in a database. Now let's see Boolean data type in SQL. It's a simple yet powerful type used to handle binary conditions. The Boolean data type is used to store true or false values. It's perfect for situations where you need to represent binary states like on-off, yes-no, or true-false. True and false. In SQL, true is often represented as 1 and false as 0. This makes it easy to work with binary conditions in your database. Let's see one example. Here, one employee ID int is integer data type. This column stores a unique identifier for each employee as a whole number, e.g., 1, 2, 3. Each employee gets a distinct employee ID to identify them uniquely in the database. Second, first name, CHAR, 20. This column stores the first name of the employee. It is a fixed-length string, which means it reserves space for 20 characters, regardless of the length of the name. For example, if the name is John, it will still reserve space for 20 characters. 3. Last name, VARCHAR, 30. This column stores the last name of the employee. It is a variable length string, which means it only uses the space needed for the actual length of the name, up to 30 characters. Fourth, isActive Boolean. This column uses the Boolean data type to indicate whether the employee is currently active. True means the employee is active, e.g., still working at the company. False means the employee is not active, e.g., no longer working at the company or on leave. 5. Is full-time, Boolean. This column also uses the Boolean data type to indicate whether the employee is a full-time worker. True means the employee is full-time. False means the employee is part-time. Let's talk about null values in SQL. Understanding null is crucial for handling missing or unknown data in your databases. What is null? In SQL, null represents the absence of a value or an unknown value in a database column. It's what you use when data is missing or not applicable. Example: for instance, if a user doesn't provide their phone number, you might store null in the phone number column. This indicates that no phone number was provided. Key point: remember, null is different from zero or an empty string. Null simply means that the data isn't available. Knowing how to handle null is essential for managing incomplete data. Now let's learn about schemas and tables. Understanding these concepts is key to managing data effectively. First, what is a database? It's an organized collection of related data. For example, imagine a database called SchoolDB that contains all the data about students, teachers, and courses. For a better understanding of databases, you can watch my first video where I explain it in detail. Next, let's talk about schemas. A schema is a logical grouping of tables and other objects within a database. Think of it as a way to organize your data. In SchoolDB, you might have separate schemas for students, teachers, and courses, each grouping related tables together. Finally, let's look at tables. A table is a structure within a schema where data is stored in rows and columns. For example, in the students schema, a students table might include columns like student ID, first name, last name, and enrollment year. Let's take a quick look at how databases, schemas, and tables work together with an example. Imagine we have a database called SchoolDB. This is the main database containing all the related data. Inside this database, we organize our data using schemas, like students, teachers, and courses. In the student schema, we have a students table. This table stores information like student ID, first name, last name, and enrollment year. Next, in the teacher's schema, there's a teacher's table that includes details such as teacher ID, first name, last name, and the subject they teach. Finally, in the courses schema, the courses table keeps track of courses with columns like course ID, course name, and teacher ID, which links back to the teacher's table. Here are the key takeaways for understanding SQL data types, schemas, and tables. String data types store text. CHAR is for fixed-length strings, and VARCHAR is for variable-length strings, making them flexible for different text lengths. Date and time data types manage temporal information. Use date for dates, time for times, and datetime to combine both. The Boolean data type represents true or false values, often stored as 1, true, or 0, false. Null values indicate missing or undefined data. They show the absence of a value, distinct from 0 or an empty string. Moving on to schemas and tables. Schemas are logical containers within a database that organize related objects, like tables and views. Tables are structures within schemas that store data in rows and columns, representing specific entities like students or orders. And that's a wrap on SQL data types, schemas, and tables. These concepts are fundamental for organizing and managing your data. This video is part of my SQL full course. If you found this video helpful, please like and subscribe to PyBrain for more SQL tutorials. If you have any questions, leave them in the comments below. Thanks for watching, and see you in the next video.